Thank you everyone for attending today. We're going to be talking about the Huawei 45 KTL and why it is the most successful inverter in Canada, specifically when it comes to rooftop solar installations right now. There's going to be 5 parts to our webinar. The first part will be a quick piece about Frankensolar, where we've come from, where we're going, that sort of thing. Then we're going to do a quick intro to Huawei, what the company itself. Then the main piece of the presentation, Alex is going to talk about the commercial and industrial smart PV solution from Huawei, and specifically about the 45 KTL. Then we're going to quickly go over the rest of the portfolio of Huawei, and we're going to conclude with a question and answer section where you can where we can unmute you, or you can unmute yourself and ask questions, or send us a chat message asking questions, and Alex and myself will do the best to answer those questions. The first 4 pieces, the main part, are going to be about an hour. We're going to try to keep it within an hour, and then the questions and answers, we're going to take all the time you need, and hopefully, answer all those questions. Under no time constraints from our end. Okay, well, let's get started here. Let me share the PowerPoint presentation. Getting it?
Yep.
Okay, perfect. Okay, so Frankensolar. Frankensolar, originally a German company, started in the Franken region of Germany back in 1990. We're quite successful there, especially in the early 2000s into 2012, 2013. And in 2011, we established a North American operation. At that time, it was based in Mississauga. Now it's based in Brampton, and we have 2 locations, one in Edmonton and one in Brampton, where we are at right now. We have helped supply over 10,000 residential and commercial systems in Canada, and currently have about 15 full-time employees. Our mission is assisting Canadian solar installers for designing high-quality and competitively priced solar projects for every home and commercial building in Canada. What that means is we're really, not just order fulfillers. We really try to help you in a variety of ways with system design, always having the best products available at the best possible price, and finding a variety of ways to increase efficiencies in your business. Frankensolar difference, being around since 1990, having long-standing relationships with manufacturers. Some of those go way back to 1990 that we're still working with. So quite long-standing relationships. Then engineering support, we have Alexander here, our in-house electrical engineer, who's worked for a variety of inverter companies, and also owns a variety of solar systems himself that he's designed. So he's quite knowledgeable, and many of you have worked with him already, so what he can add to the experience. Then we were the first solar distributor in Canada that had a price list. Same price list for all solar installers. It's very aggressive, very to the point, and it's updated on a monthly basis, so you always have the latest pricing. And then something we started at the beginning of COVID, the whole COVID crisis, was that we offered free shipping, and it's been very popular. So any order over $5,000, you will get free shipping with Frankensolar. So going into the Huawei part of the presentation now, it's funny how it all began. It's actually Peter Mueller, our CEO, back in 2016, he flew down to Boston and met with the Huawei management team. They were starting to push into the North American market for their inverter in the solar industry, and we were actually the first solar distributor in Canada, in North America, that was signed up with Huawei as an official distributor. So we've been working with them for a long time. Fast forward 4 years now, and we've been selling about 50 megawatts worth of the Huawei inverters. Most of that actually was over the last 2 years. So Huawei, most of you are aware of the company Huawei. They're a Fortune 500 company, number 61 on the Fortune Global 500, 194,000 employees globally. I think it's about 5,000 in Canada, 170 countries. So they're really pretty much every part of the planet. They started in the telecommunications sector, and everyone works or deals with Huawei on a daily basis, even if they don't know it, because about 50% of cell phone towers in Canada are made by Huawei, and all the major telecommunications companies have cell phone towers from Huawei. Actually, a fun fact too, they're number 2 in global smartphone shipments, which is quite impressive. On the inverter side, they started in about 2014. They started producing inverters, and they focused right off the bat, they focused on string inverters, as they saw a major development that shifted even in, utility-sized projects towards string inverters. I think the first ones that they had were in the 20 kilowatt range, and as you can see on this slide, every year since 2016, there's been a shift from central inverters towards string inverters. And Huawei by far is the number 1 company in global inverter shipments every year since 2015. That's been number 1 at 118 gigawatts by now. Like last year was about 29 gigawatts. Oops, what is going on here? On this slide, we can see that Huawei has a major share in the string inverter market. In 2017, which is the latest slide that I have, was 56%. Huawei has products in all the segments that we deal with. They have a residential product, which is an optimized-based inverter. They have a commercial and industrial inverter, which is the 33 to 40 KTL at 1,000 volt DC, and that's a 480 volt AC unit. And then the unit that we will be talking about today extensively is the 45 KTL, which is a 50 kilowatt, 1500 volt DC, 600 volt AC inverter. And that's really the workhorse as far as we're concerned. That's where most of the megawatts in Canada have been sold with. Then they also have a utility scale product with a 100 kilowatt unit that's similar to the 45 KTL, but it is an 800 volt AC unit. And for smaller projects, it doesn't really make sense for a variety of reasons. Maybe Alex can talk about it a little bit more after why the 45 KTL over the 100 KTL. But yeah, that's something that's more meant for utility size projects. And I'm going to pass it off to Alexander to talk you through the Huawei CNI Smart PV solution portion.
Thank you so much, Danny. Welcome everyone from my side as well. And we can jump right into the more technical part of this presentation. And I will quickly give you an overview of what we want to talk about.
Yeah, I just realized that. Apologize. There we go.
Thank you, Danny. So we want to talk about, of course, the core features of the inverter. We talk about AC specifications, what the electrical installation could look like, the mechanical installation, thermal performance of a passive cooled system, DC specs, your input voltage range, how oversizing can help you with your project. We talk about how Huawei integrated the communications parts between the inverter, monitoring gateway, and then the server system. And then we have some more detailed topics where we can talk about AFCI here in North America. We can talk about conversion efficiency and what impact that has. System maintenance is one of the bigger topics, and of course, one of the most important topics for selecting an inverter design and inverter system is the reliability of these power electronics. And then at the end, similar to the maintenance and O&M topic, the IRE Curve Tracing, which every commercial Huawei three-phase inverter has already implemented.
Not working?
Not working, okay. So the most confusing part of the 45 KTL product from Huawei is actually the name, because the 45 KTL is a 50 kilowatt unit. And the part or the reason why it's a 50 kilowatt unit is it's actually a 50 kVA unit. And we in Canada, we are working on a fairly old grid code, the IEEE 1547, which still requires the inverter to operate at unity power factor, which means a power factor of 1. So for a 50 kVA device, you actually have 50 kilowatt active power available from that unit. Most other jurisdictions, for example, in Europe or in California under Rule 21, they already require some smart inverter features to support the grid, and they require a full name output power, a power factor of 0.9. And if you have 50 kilowatts or 50 kVA available at 0.9 power factor, in these markets, you only get 45 kW out of the product. And that's why the product is called a 45 KTL. Since most manufacturers are not specifically developing a product for a very small Canadian market, we are, of course, piggybacking on the US market, and there, of course, the market name 45 KTL represents more accurately what the system can actually do. I've put the PQ diagram here on the slide, and we're operating exactly at unity power factor on that, in this case, the y-axis. The unit, however, is able to provide up to 30 kVAR reactive power, and that reactive power can be used in a multitude of applications, which are not the standard application for a grid-tied solar system, but in a microgrid scenario, for example, or if you have a power factor correction requirement, or some utility companies want to have your bigger system supporting the grid in a more advanced feature, similar to a grid code like the California one, then the inverter can already do that, is in this regard future-proof to changes in the grid code. I'll just use this now. When we jump into the electrical installation, the Huawei 45 KTL uses a three-phase, three-wire connection, which means it's not a neutral-based topology. The inverter can use a transformer which has a secondary as a delta or a Y configuration, so you're not tied to one over the other. You can pretty much connect to whatever transformer configuration on the secondary side you have. But no matter if you have a neutral or not, the inverter will not use the neutral as a current carrying conductor. And that is not very important for very small systems, but if you have extremely large systems or bigger commercial systems, it is definitely a cost saving if you can run a 3-conductor plus ground ACWU cable, for example, instead of having all the 4 conductors in your cable when it's not even utilized by the inverter. Most people in the field use a tech cable style cable to connect the inverter to their AC panels, and actually most people use an aluminum conductor. just from a cost savings perspective, that's the best bang for the buck. And in Canada, we have the ACW90, which is the most commonly used. The terminals itself is an M8 stud for all of the three phases. You see them on the picture with those blue arrows and yellow nuts. And you can use either a crimp-on, a ring lock, or what most people do, use those dual-rated locks, which are available from a multitude of manufacturers. And when we look into the design of the system, the output current of the inverter is actually 48.0 amps, which means with the sizing factors we have here in Canada or in the US, we can use exactly a 60 amp breaker or fuse to make that happen. Which is also a good thing if you have requirements that adjacent to the inverter, there has to be a disconnect switch on the AC. Some jurisdictions have that, some jurisdictions don't. You can stick with a standard off-the-shelf 60 amp size switch without having to upsize it to 100 amps, even though you're only using it at slightly over 48 amps in other systems. The main difference, as we already discussed, the inverter is connected to a 600 volt AC system, and most other inverters on the market are typically designed, again, for North America and have a native voltage of 480 volts. The higher the voltage, the more output power you can get out of the system at the same output current, because with inverters, typically, you pay for current. And if you have a 600 volt design versus 480, you already have from the start about 25% higher voltage, which means with the same AC infrastructure, so the same wires, the same breakers or switch or fuses, the same electrical panel you buy, the same switch gear, and with no additional step up or step down transformer, you already optimize the cost and the equipment you deploy versus going with a more common US-based 480 volt concept. And if we compare the 600 volt level versus the 480 volt level, we have a cost advantage based on that infrastructure savings from the start with exactly 20%, which is huge. When we quickly jump into the mechanical installation, the inverter is a passive cooled system, which means it does not have any fans forcing the air through the heatsink. And with that technology, you have to have convection cooling being built up like a chimney effect through the heatsink of the inverter, which then directly means that the inverter has to be somewhat upright installed on a wall or on a mounting structure. That's why Huawei specifies that the inverter has to be either fully upright, vertical, or can be tilted up to a maximum angle of 15 degrees backwards to maintain that constant airflow at full operation to make sure the inverter is always properly cooled. When you have multiple inverters on a side or on a rack adjacent to the roof-mounted array, then you have to have a little gap between the inverters, which in this case Huawei specifies at roughly about a foot, to have enough space for radiation from that heatsink as well. Talking about cooling, the thermal operation window of a passive cooled inverter is absolutely key for the environment you deploy that inverter. Most of those inverters for commercial rooftop systems are directly located adjacent to the array to fulfill the rapid shutdown requirements. In our case, about 1 meter, since it went down from 3 meters to 1 meter. And since those units are exposed to the elements, they typically need to have a wide enough operation window from a temperature perspective to not curtail based on over temperature. The Huawei inverter at the 50 kilowatt level can produce full nameplate output power up to 40 degrees Celsius. And the regular data sheet goes down to minus 25 degrees C for full power operation. Since we are in Canada and we typically experience harsher weather conditions and climate conditions than our neighbors in the south, Huawei has a special testing document available, which also refers to specific warranty conditions. And Huawei, for the Canadian market, warranties the unit all the way down from minus 40 degrees C up to 60 degrees C. And of course, at 60 degrees C ambient temperature, which is unlikely to occur in the Canadian climate, the power will then be curtailed. So everything above 40 degrees C will have some curtailments in power. Jumping right into the DC specifications, the inverter is designed as a multi-MPPT inverter. So in the old days, you had a big inverter, it only had one input, and you had a combiner box in the field where you combine all these strings, however many, 10, 12, or even more strings in parallel. Modern designs typically go away from that concept and eliminate the combiner box and switch to a concept where you have only two strings in parallel, and these two strings in parallel will then connect to a dedicated MPP tracker in the inverter. With the 45 KTL and the smaller 1000 volt units, you have 4 of those MPP trackers available, which also means that you have a more granular MPP tracking available to your system. So you can, for example, design the first 4 strings with 23 modules and the remaining strings with, let's say, 26 modules per string. Or you can optimize it if you have some partial shading in your system that these partially shaded or temporarily shaded strings are connected to one MPP tracker versus the other ones are sharing the other available MPP trackers on that system. The input voltage is fairly wide for such a high power 600 volt AC device because the inverter, as I said, with the boost converter and the MPP tracker in the unit is a dual stage inverter. That means the voltage will, or the input will first go to a boost converter, then it goes to the DC link in the inverter, and then the final inversion stage, the actual DC to AC inversion, happens in a secondary stage. Versus some other commercial products are designed as single stage systems, where you typically have a much more narrow operation voltage window for your string sizing. The inverter starts at 600 volt. That's typically on the very, very low end of the spectrum, and you will typically, if you've done your string design properly, you will never reach that point, but it can go down to those lower voltages in a partial shading condition, for example. The system voltage, as Danny mentioned, is 1,500 volts, so you cannot exceed that voltage under any circumstances, otherwise the inverter and DC capacitor will fail. So with any string design, you design for your typical target temperature in the winter. Let's say you have a design at -35 or -40 degrees Celsius, and you adjust with your temperature coefficients of your module. And that leads typically to the following string designs. For the majority of Canadian climates, we see something between 23 and 26 panels per string. And that's a very good string design because the approach is with any transformerless inverter that you want to be always on the high end of the spectrum when it comes to string design. Because at that point, you have the best input voltage, which is high enough that the boost converter doesn't have to work as hard, which helps you with the conversion efficiency. But at the same time, when the temperature and the ambient temperature gets hotter and your panel will exceed higher or much higher temperatures, for example, your panel will be then at 50, 55, or even 60 degrees Celsius, that your input voltage to the inverter is still within the range where the inverter is able to output full nameplate power, and you're not going into that last segment where you have less power available just based on curtailment of the boost converter. There are some climate areas, for example, Southern Ontario, we have customers who design with 27 panels, but to play safe with modern higher wattage panels, which are typically having a little bit higher voltage as well per panel, the 23 to 26 panel is a design which works in almost all cases in Canada. It didn't click. Okay, try now. Thanks, Danny. Another topic which is extremely popular over the last few years, and we've done many education sessions and webinars about oversizing. In the early days, it was more like oversizing for residential systems. Today, we see a lot of installers and EPC companies really utilizing oversizing for the best economic efficiency in a changing market, when it's not a market based on the feed-in contract anymore, where you were limited by your contract size, like in the old FIT days in Ontario. Now you have only an AC capacity limit typically for most utility companies, but you are free to design your solar system in a size which makes sense for your specific application and your customer's application. Out of the box, the 50 kilowatt inverter has 4 MPP trackers, 2 strings each, which means we have 8 strings per inverter. And if we take the longest string design possible at 26 modules, we have the 8 times 26 times, let's say, a general 400 watt panel at 72 cell. We get already 83.2 kilowatts, which we can physically and electrically connect to that inverter, which leads us directly to a DC to AC ratio out of the box to 1.66. Huawei, with one other company, are the only inverter companies who have no fixed DC to AC ratio in their documents, and also no fixed power limit you can connect to the inverter. The criteria, what you can connect, is solely focused on the maximum string length based on voltage, so you cannot exceed the 1,500 volt string design, which is obvious, and you cannot exceed the short circuit input current of the inverter. With the 45 KTL and the smaller ones, you have per MPP tracker 30 amps ISC available. So typically, even with a larger, higher wattage, or even the highest wattage panel, let's say a 430 or 440 even, and even bifacial types of those panels will not exceed typically the 15 amps ISC. So we can go to an even much higher DC to AC ratio out of the box. There is, however, a second option where you can also scale your DC to AC ratio, and that's for application where the out-of-the-box 1.6 or 1.8 is not sufficient. If you want to go significantly above the 2:1 DC to AC ratio, you can not only scale the DC side of the system, but you can also scale the AC side of the inverter. We offer derating services that if you have a special contract, for example, 500 kilowatts AC, you are allowed to connect to your grid with your commercial customers. And instead of 10 inverters, you can use 12 inverters. And if you do the math, if you derate every single inverter to about 41.6 kilowatts, you will still maintain the 500 kilowatt contract capacity, but at the same time, by reducing the AC capacity, your DC to AC ratio will increase over that limit we had before. And that's a very powerful and very flexible tool to really optimize your system based on the application you and your customer have and the limitations they can see based on, for example, their existing transformer on site, their bus bar rating they have with the existing electrical panel, without going all the way or changing all kinds of things which are not necessarily making any more money for the customer or lowering the cost of the system, because a panel, electrical panel or new transformer is only a method of getting more solar in if you want, but it's not producing any kilowatt hour more for the system efficiency.
And it's important to remember that Huawei will not void the warranty if you do large oversizing, unlike most other inverter companies which will void your warranty if you go 2:1.
It's specifically allowed to size to those two factors, 1,500 volt again, and the short circuit current limit of 30 amps per MPP tracker. When we look into communications, Huawei is a communication company, and they have two typical systems built into the inverters, the three-phase commercial ones. The one is one you probably have used already in the past. It's a very proven and reliable old-fashioned RS-485 communication. You daisy chain all the inverters. The inverters are connecting then to the Huawei Smart Logger, which is their communication gateway. And then the communication gateway processes all the data and will forward that data to the Huawei NetEco monitoring server. That's one option when you want to run a wire. Huawei also has a special PCB built into each inverter, which is a power line communication, which then modulates the communication signals and the data onto phase 1 and phase 2 of your three-phase system. And the Smart Logger 2000, which is the other end of the interface, will then take the load or the data back off the AC, and you don't have to install any wire. There are limitations, of course, to that technique, because the PLC is restricted in length. If you have a multi-core conductor like a tech cable or an SW, your capacitive coupling between the conductors is very good. And at that point, Huawei guarantees that you can go up to 300 meters of length between the last inverter in your system, which is the furthest away from your AC cabinet, and the smart logger on the other end, picking that data from the AC cables. Most people, since the RS-485 installation is very simple to do and very inexpensive, typically use the RS-485 just because you have an extremely robust communication system available. You can go much further than 300 meters, up to slightly over a kilometer. And if they are arranged in a group of inverters, you can actually use RJ45, even a patch cable, because the Huawei inverter has terminal blocks where you can land the conductors on there if you just run a wire, or you can just get the RJ45 patch cable with a RJ45 terminal to patch them through without any screw connections and terminals, just by plug and play. Jumping right into, thanks Danny, the NetEco Server. That is the online-based cloud server. We are hosting our own for the Canadian market. And all the data the smart logger will connect is reported and then pushed to that server. And you can log in with your credentials. I've just put in 2 screenshots to not talk about too much about the features because it can go very deep. There are a multitude of functions available. You can have just a basic overview over what the system is doing on the top picture, and you can go deep into the detail for every string, single string current of every string connected to that inverter. What you get in real time, the data is typically delayed about 2 to 3 seconds, depending on your internet connection on site, and you can live monitor what the system and every single string of the system is doing. Furthermore, there are some smart communication features available where you have a true bidirectional communication. So you can change parameters from the comfort of your office. You can initiate reboots. You can shut the system off. You can do self-checks. There's a function called Inverter Patrol, which goes through your whole portfolio, self-checks every inverter. The inverter is reporting. They're finding, is my AC okay? Is my DC okay? What's my ground resistance? Are my grid relays stuck or not? Is the communication there or not? If it's not communicated, of course, it gives a communication fault and all kinds of features. And what you get at the end of that test is a PDF document, which shows you the inverters which might have some issues, for example, high AC voltage. And all the other ones are also listed, but they are not in focus. So with that feature, you really have that clear focus on what are the devices and your assets in the system or in your portfolio which have some issues, and which are the ones you don't really have to look into because they're not operating normally. In the system, you can also implement a multitude of different environmental sensors or smart meters. We typically use the AccuRim from Accu Energy as a very popular tool, and that can be used for zero feeding applications or feeding controls for closed loop reactive power control and all kinds of smart application when you're not only having a grid-tied solar system. Next. If everyone or if anyone is interested in a more deep dive analysis and presentation of that NetEco Portal, we have done many presentations for different companies to walk them through the system, what it can do, what kind of services there can be had with that system, how we can use IRE Curve Tracing with that portal to go through every single string in the system. We talk about that later a little bit. And all kinds of data export protocols, on-site analysis, down to the fact that you can really pinpoint the problem before you even send someone to site. And that's a huge game changer when you will be looking to O&M costs and how large portfolios are managed to make that more and more efficient in a more complex market.
Yeah, and we will be, like Alex said, we'll be very happy to set up one-on-one tutorials with Alex and your team to walk you through that NetEco platform. and answer any and all of your questions on a more one-on-one basis, because it can, like Alex said, it can be quite...
It's extremely powerful, and it takes about 45 minutes typically to go through that. So we don't want to go too deep into that, to keep it short and focus on the 45 KTL. But anytime, I'm happy to jump on a call and share my screen that you can actually see real life sites in real operation, how it works and what it can do. Another very important field is documentation of the product. We have consulted and sold and advised many engineering companies and EPC companies in their applications with utility companies, and I can say for sure we have probably 99% of all the data sheets and all the statements and short circuit current testings and performance data and third-party testing and AFCI statements, anti-islanding, CSA test reports, compliance certifications, protection philosophies. I think we have 30 or 40 documents for all kinds of things, down to noise level, simulation tools for PSCAT, OND files, pretty much whatever you need, we have it available with a click of a button. And a lot of our current customers already know we can send that out within minutes of you sending me an email. And I'm happy to share that data whenever there is a question, or if you need something specific and you don't know where to get it from. It's a real, we have it when you need it as quickly as possible. Exactly. Now we want to talk a little bit about some other features which are very common and required in the North American market. They're not so much required or not at all required in the rest of the world. And AFCI, for example, so the arc fault circuit interruption is one of them. And arc fault in the past, when it was introduced under the National Electric Code in the States in 2014, was a little bit of pain because there were a lot of not fully developed arc fault detection systems in the market from multiple manufacturers, and that led to many people having issues with AFCI fault strips, and it didn't work the way it was promised, or it had issues at very cold temperatures from an electric noise perspective. And a lot of that stuff got resolved, and we can talk a little bit about what Huawei is doing it and what the causes typically are for these arc faults versus a fault strip based on an arc fault message or a fault stripping. So the most common effect or root cause for an arc fault in a system actually are the connectors of your DC system. So a lot of installers may be in a rush and they don't pay too much attention on how the crimp is actually done to have the right connectors. The matching connector requirements we have today is really an effect and a result out of that early issue scenario. And my recommendation is pay a lot of attention for your team and your installation crew to really take your time for proper crimp and a proper tightening of the grommet at the end of the connector. And that does apply to pretty much any manufacturer. If it's an MC4 or an Amphenol H4 or some Chinese knockoff of it, doesn't matter. They're all structured in a very similar fashion. The crimp has to be good. The connector should not be exposed to the elements for a prolonged time. So if you install, for example, optimizer on a roof, don't let the optimizer sit with open ends for a week or two or even longer, because if you are close to the ocean and you have a lot of salt spray in the air, that leads to corrosion of your connector. And typically the connector is intended to be installed, plugged in, sealed shut with the mating pair. And then it's in its environment where you have the proper contact resistance and everything. Then there are some other issues, typically in the modules, for example, or in the wiring. But when we look into the top 10 module manufacturers in the world, the possibility of having issues with those manufacturers dropped significantly over the last 10 years. So the manufacturing quality from a fully automated manufacturing facility is extremely high compared to what it was 10, 15 years ago. So that's statistically a lot less common than the actual physical installation of the connector. Huawei is certifying their AFCI detection circuits as any other manufacturer under the UL1699B. And Danny is displaying here a video from a typical ARC scenario. And with a DC arc situation, opposite to an AC arc scenario, a DC arc can be maintained for a prolonged time and is not extinguishing itself based on the pure structure of a DC incident. And that prolonged arc can cause or has a lot of heat and a lot of energy in it and can lead to fire incidents and burning some shingles or whatever you have on your roof. And that's why AFCI was introduced into the solar installation for rooftop systems, mainly, some exemptions, in North America. Fun fact is here that none of the other markets in the world, Europe, Australia, the Chinese market, or the Asian market, none of the other markets do require AFCI to this day.
You want to talk quickly about the different levels of AFCI settings?
Exactly, yeah, that's something I want to also mention. Huawei, that's one of the slides too,
okay.
Has certified the AFCI detection not only for the minimum requirements of 80 meters, so that string cables can be 80 meters total long. Like many other manufacturers today, they also certified it voluntarily to up to 200 meters. So even if you have a group of panels on a commercial rooftop, you're not restricted by just 80 meters to still be within the UL 699B certification level. The other thing is the minimum requirement is 16 amps for the AFCI detection and shutdown. Huawei also went above and beyond that and went all the way to 26 amps to accommodate for a higher wattage panels or bifacial panels in certain conditions where the bifacial, the backside, contributes significantly to the current of the system. And in that scenario also, Huawei is the only manufacturer, to my knowledge, that has certified AFCI to 3 different sensitivity levels. And that's an extremely important difference to some other companies, where most of the companies only have one level. It's either that level, the AFCI is switched on, or the AFCI is switched off. That is all you can do. Huawei actually has certified to a medium sensitivity, which is the default, which comes with the inverter pre-programmed. But you have a higher sensitivity level, and you have also a lower sensitivity level. And the lower sensitivity level can be used in an industrial application where you have, for example, a metal shop in the building, where they have some variable frequency drives or some higher EMI levels in that building to have an AFCI detection circuit which is more resilient to that higher commercial noise level versus a system which is just not adjustable at all.
It is also important to note that the Huawei 45 KTL is the only 1500 volt DC inverter that does come with AFCI out of the box integrated in the inverter. And the reason for that is fairly simple. The other inverter companies did not integrate AFCI because in the US, commercial rooftops are limited to 1000 volt DC strength. So this inverter would not be working for a US rooftop. It's really a product that is ideal for the Canadian market. Additionally, I don't know if you're talking about it after, but the 600 volt AC also comes into play, as the Canadian market is probably the only market in the world that has a lot of commercial businesses connected at 600 volt as opposed to 480 or 400 in the case of Europe.
Exactly. Thanks, Danny. Next one. When we look into conversion efficiency, in the past, conversion efficiency was always a big sales argument. You have to have the highest efficient inverter, and that saves you or produces so much more money and everything. Today, it's more a feature to enable other features to make the system more user-friendly and more cost-efficient. If we look into an inverter which has, let's say, a 98% efficiency, at a 50 kilowatt unit, you have about slightly over 1,000 watts in thermal losses, which have to be dissipated over the heatsink. If you have an inverter which is, for example, just 97% weighted CSC efficiency, you already have 1,500 watts of thermal losses that have to dissipate, which means from 1,000 to 1,500 watts losses, you have 50% higher losses, which means that your cooling concept has to be designed 50% bigger to accommodate the same 50 kilowatt AC output. And that's the pure magic where today high efficiency is not really a sales tool anymore, or that you make a lot more production versus a much lower efficiency unit. It's all about enabling the secondary features that you have a compact, high density unit, so the power to weight and the power to volume ratio, and enabling just an effective cooling method for a wide input voltage range without having to deploy forced air cooling methods, that you don't have fans in the system, which might fail over a certain time and you have to replace them and things like that. And only as a secondary thought, you can look into what is my production gain based on the efficiency. And if you have a high efficiency inverter, let's say 98.0% CEC weighted efficiency versus the Huawei 45 KTL here, which is CEC weighted at 98.5, the delta is only very minimal, but you still get it. So it's still an advantage for you, but it's not the main focus point of inverter concepts today, and that applies pretty much to any inverter on the market from any manufacturer. The most important thing we want to discuss today is not about if the unit has 50 kilowatts or 600 volts and all these bits and pieces, which are amazing, but the most important thing for an inverter in these days is the reliability and what it means to your business long term when you provide O&M services to your customer. And I tell a lot of people, the best inverter concept or inverter you have, no matter what brand, no matter what color, is the one you install, you commission, you switch it on, you turn around, you walk away, and you never look back. If you can have such an inverter that is so valuable, and that's more value than a cent saved here or something back and forth, it's really the peace of mind that the asset you deploy is just operating without you losing any sleep over it. And that's the core strength of the Huawei 45 KTL, because it is extremely robust. And the main reason why that's the case is the clear focus on taking everything out which is not needed and is known to have failures in the field. For example, a fuseless concept removes all the trouble with fuses at high temperature, for example, and the unreliability, because with two strings in parallel with the CEC or the NEC, you don't need any fusing because you have an MPP tracker for a group of two strings each. So there's no combining of strings beyond that two strings in parallel. That takes care of that. With a high efficiency passive cooled system, that completely eliminates the requirement for fans. Fans typically, if you have a higher quality EBM PAPST, for example, they're typically rated between 40 and 80,000 hours of runtime. And that sounds great, but that runtime is under ideal conditions, typically in a lab. If you put that inverter in an environment, on a farm, on a roof, for example, in a Canadian climate specifically, where you have fairly high temperatures in the summer and you have extremely low temperatures in the winter, that's not going to help and increase the longevity of that fan. So for most systems, within the first 10 years, there's definitely one fan replacement. And most other companies who do have fans actually have fan brackets available to change the fan easier. But if you don't even have a fan, that topic is completely off the list, and you don't have to worry about any cooling issues based on failed fans and things like that. Same applies to displays, buttons, and all those things. It's nice to have, when you install an inverter, to have a display that you can see, a nice diagram and all the grid code and the power it's producing. But honestly speaking, in a commercial rooftop, you place the inverter, you install it, and there's no one really walking to the inverter and looking at the display in real operation in year 5 or year 10. It just has to work, and that's it. So removing that part, removing the cost, and removing the possibility of that being a failure point really is a great feature to optimize, and focusing it on what's most important for an inverter. It's invertering without any
well, besides the fact that you can access every inverter remotely or via the smartphone app and the smart logger.
That would be my next half sentence.
Beat you to it.
No worries, Danny. With the Huawei concept, the focus is addressing all the questions of the system and the data from a central location, and that can be either the location where you install the smart logger, so your on-site gateway, or from the web portal, the NetEco, that you don't have to walk to any inverter and look on the display what's going on, that you really have the data available before you even go to site or send someone from your O&M team. Huawei has a little bit of funny number here, $11,000 one back at O&M for O&M costs, the operation costs, in a 20-year span. That means $550 US per year on a megawatt, and for example, an Ontario FIT contract at 500 kilowatts, that would be just $275. I don't know where they have that number from, but in Canada, every single truck run, if you go to a bigger site, plus the labor cost, plus the truck and everything, will already be much more expensive than that $11,000 figure. So we can see O&M costs which are significantly above that number. And again, if you have a toolbox available which optimizes the number of runs and you have to site and the time spent on site, that really helps with your O&M offerings, or when you have performance warranty guarantees, for example, to really focus on what you can do best, and that's typically not in fixing old systems which break, that's typically installing more solar. Next one. Okay, so as a quick overview, reliability is achieved by removing parts that wear and to really design an inverter which is focused on no touch concept. So you don't have to do anything, there are no buttons, it's really all programmed. If you wire up, for example, the RS485 to the inverter, you don't even have to set any IDs for each and every inverter. The smart logger together with the inverter is auto-assigning IDs to each and every inverter in the field. So when you take out the inverter out of the box, the inverter already comes pre-configured with the IEEE 1547. And once you hook up the AC and DC and you're monitoring, the system would already be code compliant to start right away with you not doing anything. No cell phone app, no display, no button key in, no passcode, no nothing. It literally works out of the box. And all that together with removal of the components leads to an extremely high reliability and extremely low failure rate. So Huawei typically states that the failure rate, the annual failure rate, is below 0.5%. That means within 1 year, only 0.5% of the deployed units are having some issues. They have some studies which were audited by TUV in Europe, and they show for big systems, I hope you can see it on the bottom, that the failure rate is somewhere between 0.1 something and 0.39%, which is extremely good. Back in the days when I was still working in the engineering for inverters, in Europe, everything below 1% was already thumbs up kind of thought, and a lot of products at that time or in the North American market had failure rates which were significantly above 0.5%. So having such a concept which is reliable is really helping you focus on what you can do best and not fixing old issues. Okay, what's the next one? IRE Curve. We already had a quick overview over the IRE Curve Tracing. I don't want to spend too much time into it because that's a topic for another hour. We can talk about what can be done, how it's being done, what the export is, and the feature. The main message is that every Huawei inverter with its string level monitoring and the string current monitoring as well has the capability with the MPP tracker to scan the whole input voltage range of the inverter to give you the measurement of the IV curve of every single string. And that can be done completely remotely without disconnecting any string of the system at all. The scan typically takes about 2 minutes, and the inverter will power down in those 2 minutes and will then ramp up its power to go through that IV curve. and every inverter will collect that data internally, will transfer to the smart logger. The smart logger is also processing that data in a package, will upload that to the NetEco, and then it will be available as a PDF report, which you can download, and you can configure that with your own logo and your own whatever name of the system or whatever kind of additional information you want to put in that system, and can use that as an O&M report if you have an O&M contract, for example. And that's something which is extremely powerful, maybe not in year 1, maybe not in year 5, but once your system gets older, talk about year 10, year 15, year 20, that having a system where you can super easily check the whole system and not just a small sample size where you send a guy with an IRE Curve Tracer, which is whatever, $14,000, $15,000 at 1,500 volts out, and they test a few strings in the system at high cost. No, you can actually do it from your office around noon when the sun is up and have that data available. I'm certainly happy to walk you through such an operation on a test system. Huawei also has test licenses available if you have already a system where you can play around a little bit with that feature. And it really helps to pinpoint, for example, diode failures. That's one of the more common ones. Hotspots can be detected and things like that. It's all about how the data is provided to you, and Huawei, again, similar to the Inverter Patrol, has a feature where the IRE Curve Tracing and the reporting of the IRE Curve Tracing focuses on the deviation from the norm. So you can, of course, go through 1,000 strings and 1,000 diagrams yourself and do the analysis. That's certainly possible, and you have the data available. But it's really of value that you focus on the strings where the inverter system and the automatic analysis told you there's something wrong compared to the other systems, or something out of the ordinary. So you can focus on whatever the 10 strings of your portfolio, which is a little bit outside of the ordinary. Next. We have a very quick sample case in the UAE. Huawei has a portfolio of about 25.5 or 25.6 megawatts. And that's based on the 40 KTL in this case, the European model, which is extremely similar to the 45 KTL. It's just 1,100 volts instead of 1,500 volts, and a little bit lower output power. But the thing is that with that no-touch concept, really focusing on what's most important, the whole portfolio has absolutely no issues and no O&M runs in the first 2 years since the system is installed. Of course, something always can happen with a system. Huawei is not completely free of defects either, but the focus is really make your whole portfolio as bulletproof as possible with a simple, a uniform design, that all the systems ideally have the same count of strings, the same number of panels, because that really makes O&M easy for the future when you send people to site, a uniform and easy structure.
Yeah, and we can speak from personal experience as we are hosting the Huawei monitoring platform NetEco on our server. We see the production of all inverters and most of all failures, and we have seen almost no failures whatsoever within the 50 megawatts or so that are on that NetEco platform.
And we are not afraid to show you that in that live view.
Yeah,
so that's absolutely no secret. To really sum it up very quickly, since we're already at the end of our hour, Huawei really focuses on what's most important in your system to make your system as cost-effective, as flexible, as efficient, as reliable as possible, at the same time comply with all the safety requirements you have on those rooftop applications. And that's a multitude of things, as we discussed. We have the very advanced AFCI detection. We have 2 strings per MPP tracker, which gives you flexibility in the string design. It's also more flexible for partial shading, for example. Huawei also has a global MPP tracking algorithm, similar to some other manufacturers we carry. It is extremely efficient in the conversion efficiency, which then results also in a wide temperature range. For older systems or panels which have PID issues, you can use the inverter out of the box as a PID recovery system. It needs an external transformer to offset the ground, but that's a different topic. It has no fuses, and it removes all the parts which typically have issues in the field or are proven with other concepts in the past that these are issues. It's a fully natural convection cooled unit. There are no fans. It's a fully sealed NEMA 4X design, just for, again, high reliability. And on top of all that, you have the data on your hands to really compare any data point in the inverter. For example, you can compare string 1 of inverter number 14 of your system with string 7 of another inverter off the same side or on a different side, and any combinations in between, because there are comparison features available with any parameter, temperature, AC voltage, AC current of any phase or device. It's really, really flexible. And most people will never need that granularity of data. But if something happens and you do have a problem and you really want to dig deep with your O&M team, what is the root cause of my problem? Is it high AC voltage, for example? Do I have a ground fault on my DC side? That data is really valuable to dig into it before you spend money with getting a truck rolling and someone standing in front of the inverter and just guessing what could be wrong right now.
Before we get into the product portfolio, the entire product portfolio, I want to quickly go over some of the highlights that we've talked about. So the major features of what we have here is it's the only 1500 volt DC inverter, a 1500 volt DC string inverter with AFCI in the North American market, or in the world really. So that is something to keep in mind. So if you want to use 1500 volt, this is really the product to go to, because it's no other inverter has AFCI integrated, and you really don't want to spend the money or the headache with going with a third party AFCI. It comes at 600 volt AC, which is amazing for the Canadian market because it really saves you a lot of money. You don't need a transformer to step it up from 480 to 600. It does have IRE Curve Tracing, two-way communication with the NetEco platform and the inverter, so you can send commands from your office to the inverter, check for AFCI issues, all kinds of things, without actually going to site. It allows for very large oversizing if that's needed. And most importantly, the failure rates are absolutely minimal, almost zero, basically at 0.25% or 0.3% annual failure rates. So, without, let's quickly go over the rest of the portfolio. We will only spend 2 minutes on this, and then we go to the Q&A section. So there is a product for the residential market, and that's the Sun 2000 3.8 to 11.4 kilowatt inverter. It's a single phase product, and it comes with optimizers. So every panel requires an optimizer. So that's that product. It's quite successful. It's very inexpensive, especially compared to some of its competitors, about 30% less than its major competitor there. Then we have a 480 volt unit. That's a Sun 2000 33 to 40 KTL. So that's 36.6 kilowatts to 44 kilowatts. Similar reason as the 45 KTL. Canadian market has the power factor of 1. MPPT voltage range is 200 volt to 1000 volt. It has all the same features as the 45 KTL, so the remote two-way communication, the arc fault, the smart IRE curve diagnosis. Then the 45 KTL, as we talked about, and then the last is hidden behind a window here. That's the Sun 2000 100 KTL HV, and that's the 100 kilowatt unit that they have. Similar voltage window as the 45 KTL and all the same features. The only major difference is it has 6 MPPTs and 12 inputs as opposed to the 4 MPPT 8 string of the 45 KTL. So,
and the major downside, as Danny already mentioned, is the 800 volt AC concept, which is not standard. So all the breakers, electrical cabinets, wires you buy, everything has to be rated for that 800 volts or higher. And unfortunately, the cost savings you will have on the inverter, which will ever 0.4 cents cheaper or something like that, is eaten up multiple times over by non-off-the-shelf components, which are extremely expensive compared to just a regular 600 volt switch, fuse, AC gear, and so on.
Okay. So we've had a number of questions, and please feel free to keep adding to the list of questions via the chat. That's probably the easiest way. I'll just read them, and then Alex and myself, we can answer them as we go. First question is from Parker, and it's asking, regarding mounting conditions, are there any plans to get the inverter approved for low slope mounting to mount directly on the ballast racking?
That's exactly in that direction when I talked about the mechanical insulation and the convection cooled system without a fan. So based on the fact that a chimney effect has to be built up through the heatsink to actually dissipate the heat of the inverter, you cannot install the inverter in any low slope application on a roof. So you always need some kind of racking structure. Most people use Unistrut and build their own racking structure because that's the lowest cost racking option on the market, and that will really address that mounting system. So it's not possible to go lower than the 15-degree tilt backwards with that inverter.
And that's strictly because of heat?
And that's strictly because of the way the passive cool system is. So if you would do it completely flat, there's a lot less air going through the heatsink. So the inverter will not be able to produce full power at 40-degree ambient based on that limited heat dissipation. And at that point, you might be able to get whatever 30 kilowatts out of it or something like that. But of course, that's neither approved nor tested by Huawei, because the approach is if you buy a 50 kilowatt inverter, you typically want to use it at 50 kilowatts with some exemptions, of course. But the cooling aspect should definitely be as ideal as possible. So with any inverter.
Okay. Are you losing your warranty if you derate it to, let's say, 30 kilowatts, and you're okay with the fact that it would only produce?
You will not lose your warranty based on the fact that the inverter is self-limiting.
Okay.
So if the inverter gets too hot and feels like the heat cannot be dissipated and the internal components are running at higher temperature than they would be at a full vertical orientation, the system is still warranted, but you just not get the power out of it.
You're not getting full power or any power?
You're not getting full power out of it.
Okay. So if you're okay with 20 kilowatts out of it, then...
Or maybe 15 kilowatts if it's hot outside, that's something. But we would not recommend installing it flat. For flat applications, there are other products on the market.
Or using specialty racking to lift it up, even on a roof, maybe possible. Next question, is there a string sizing tool available?
There is no string sizing tool available, based on the fact that it's extremely simple for the majority of applications to design your string. It follows the same string sizing guideline as any other string inverter on the market, no matter which brand. The only difference is now you're looking at the 1,500 volt design instead of a typical 600 or 1,000 volt. As I said, the majority of the systems use 72 cell panels, regular panels, and then you will be somewhere between 23 and 26 panels in series. If you have specialty panels, like some Panasonic high voltage, low current panels or something like that, we can certainly help you out getting a string design. And
in any case, we can help you with string design
extremely quickly. I've done many string designs in my life, and we can help you out with any module you have.
Yunji asked about comments on bifacial module matching.
So bifacial modules typically can have a higher output current depending on how much reflection you assign from your ground or from the structure beneath the panel being reflected the backside. That's always a tricky question to ask. How much is that, and how much of that radiation will actually translate into more power from that backside? Most bifacial module manufacturers have a table where they say 5, 10, 15, 20%, whatever it is, bifacial gain, and you pick the gain which is appropriate to whatever you predict with your installation thing, and that will be the current which you will be using for determining if you can connect that to the inverter MVP or not. As I said, most current panels in the market are significantly below the 15 amps in real-world ISC current. and that's the limitation. So for all the 430 watt bifacial panels, even at the highest possible bifacial gain, you will not hit the 50 amps. So that's not a problem.
And then there's another comment from Junji about clipping on a 2-to-1 ratio.
So in general, we would recommend that you always simulate your commercial designs with a simulation tool. There are plenty on the market, from PV6 to Helioscope to Aurora to PV Sol, whatever you want to use. Most of those systems or simulation tools can very precisely predict the curtailment losses of a system at any oversizing. Doesn't matter if it's 1.2 to 1 or 1.5 or even a crazy oversizing, which is above 200%. And that gives you then your curtailment or clipping losses. Yes, there are clipping losses, but as I said, in most scenarios where you are looking for the lowest cost per kilowatt hour for your customer, it makes sense to test a little bit the grounds, what difference the DC sizing will make on a given AC capacity you want to achieve, and how many kilowatt hours you can get with that structure.
Yeah, and that's something that has changed over the last few years. Back in the day, 5-6 years ago, solar panels were very expensive, and we really wanted to make sure to have as little clipping as possible. In the meantime, as you all know, solar panels have become very inexpensive in comparison to back in the day, and also in comparison to the overall system cost. And the amount of clipping that is acceptable has gone up significantly. So when we design a system, we really want to usually, and there's different applications and different regulations that we have to follow, but usually getting the lowest cost per kilowatt hour produced is what's important. And oversizing brings down the cost per kilowatt hour produced in general. And then there's also situations where customers have a limited AC capacity, and let's say there's a 1 megawatt PPA, and you want to get the maximum out of that PPA as far as revenue is concerned. Oversizing is helping you significantly with bringing up that revenue. And also, we just recently did a sample case where it also helps bring up the ROI of the entire project. Next question. Can customers order derated or a mix of derated inverters as well as just standard factory inverters? Simple answer to that is yes, absolutely. We can derate it to anything you like. We've derated 45 KTL to 10 kilowatts in some scenarios because that's what the contract size was. And
it was still cheaper compared to going all the way with transformers and everything.
Exactly.
So it's a really funny application. It's not common.
It's not very common, but I'm assuming in that scenario, the situation was that there's a certain AC capacity. The DC probably was not very large either, and there's a 600 volt AC connection, and the inverter was chosen because of the 600 volt and the savings that came with it. What else do we have here?
We have rapid shutdown. That's a very good topic. Thank you, Jim. So for the Huawei 1500 volt system, there is no real rapid shutdown solution on the market. And the reason for that is, as Danny said, the NEC in the US does not allow rooftop systems to be designed with 1500 volts. And most companies who in the past developed rapid shutdown solutions developed them primarily for the US market. And the Canadian market was more a side business for them based on a US product. That is not the case anymore since the US for most states moved to a panel level rapid shutdown. So yeah, there are no real shutdown solutions for 1500 volts anyways on the market. The other thing is a rapid shutdown solution. If you would contract a company building you a custom-made rapid shutdown solution with 4 inputs and whatever 8 contactors for positive, negative at 1500 volts, that box will be extremely expensive. So at that point, you have about about the cost of the inverter will almost double just based on your rapid shutdown concept.
So what we recommend in this situation is this is still a very, very good solution, probably still the best solution to go with. However, you have to place the inverter within 1 meter of the solar array, and then you meet rapid shutdown requirements because the inverter itself will act as the rapid shutdown unit.
Or is within the parameter where you can have.
Then Parker asked about the shroud that Huawei has. The problem with it right now is that there is not enough demand for us to stock it. They have minimum requirements of a few hundred pieces, and most people don't ask for the shroud, so we don't stock it. And yeah, that's kind of the issue that we have. I think we've talked about it already, Parker. If there is all of a sudden much more demand, then we would be very happy to stock that unit. Just right now, we would be sitting on that product for forever, and it is not a cheap product. Okay, if there's no other questions, or if you do have a question, please ask right now. But if there's no other question, that would conclude the webinar for today. Again, I'd like to thank everyone for attending. Thank you, Alex, for the in-depth look into the technical side of the inverter. And yeah, if anyone has any questions, please reach out to myself, to Randy Fascinato in Eastern Canada, to Natalie in Western Canada, or of course to Alexander Direct or myself anytime. Thank you very much, and
thank you.
Thank you. Bye.